Good day, everyone. Today we are going to discuss Module 1, Unit 1 of our subject, which is IM 101. Now, let me clarify that this lecture will be used also for our laboratory. Now, after this lecture, I have assigned particular task under our laboratory section or laboratory part of our lecture. So please proceed to the laboratory section of this subject afterwards. Now, before we begin, kindly click on the modules link. Now, under the modules link, we have Unit 1, Information Management Concepts and Fundamentals, and Understanding Database Management System and its History. Now, preparing for the things you need in the lesson. Now, this is for our lecture part. Now, if you click on this particular link, as I have discussed there, what we need before the midterms is simple pencil and paper, and notes or notebook. Now, we are going to use a particular device or equipment later on after the midterms exam up until the final term. Okay, so right now we do not need to have any complicated device or gadgets except for the device that you are using to access our current lecture. So let us go back. Okay. Now, for this unit one, what are the essential questions or what are the important questions that we need to learn at the end of this lesson? First one is, how is a database management system defined? When we say database management system, what is the meaning of that particular term? Okay. Number two, how did the database management system evolve? How did the term database management system change from time to time? Okay, so basically database management system have evolved depending on the needs of its users. Question number three, what are the advantages of using such database management system? And then the last one, what components comprise a database and how do they function? It is important to note what particular parts or components make up a database in order for us to know and realize the importance of a particular database system. Now, intended learning outcomes. So hopefully at the end of this lesson, we are to know the following: the history and evolution of database management system, the reason that database management system is used and it's evolving, why is it evolving, and then lastly, the different elements that comprise a database. History of database management system. So the first general purpose DBMS. Now, the term DBMS, okay, the term DBMS pertains to database management system. So, DB is for database, M is for management, S is for system. The first general purpose, meaning it can accommodate different tasks or function, was designed by Charles William Bachman III at General Electric in the early 1960s. So General Electric, that is a company which was founded by whom? If you will recall, or if this has been discussed in your history or science lesson, GE or General Electric was a company founded by Thomas Edison, the inventor of the light bulb. Okay, so imagine from the light bulb to database systems, GE has been a pioneer in different technologies, not just for the United States, but also for the world. It was called the Integrated Data Store. Sometimes they also call it as IDS. Okay, so IDS or Integrated Data Store is the first general purpose database management system. It formed the basis for the network data model, okay, which was standardized by the Conference on Data System Languages or CODASIL, and strongly influenced database systems through the 1960s. Bachman was the first recipient of the ACM Turing Award, which is the computer science equivalent of a Nobel Prize for work in the database area. He received the award in 1973. Now, if you are a computer scientist or if you are working in the field of computer science or information technology, once you receive the Turing Award, basically it is the equivalent of the Nobel Peace Prize. So the Nobel Prize, if you are not familiar with it, it is an award given to people who have used their fields, whether it be science, whether it be journalism, whether it be politics, in order to promote peace. So the Nobel Peace Prize was, if I'm not mistaken, it was built up by Alfred Nobel. Alfred Nobel is the one that created the formula or developed the formula for dynamite or TNT. So they use it for what? They use it. He developed it for mining, but unfortunately, it was later used for war. So that's why Alfred Nobel thought of giving back to all the victims of his invention by putting up a Nobel Peace Prize. Now, going back, so the equivalent of the Nobel Peace Prize or the Nobel Prize is the Turing Award for Computer Science or and Information Technology. Now, if you can see here, this is figure one. This is the basic structure of navigational codicil database model. So let me explain how this one works. So the first image, as you can see, we have here, these boxes are basically, you can think of it as objects. Okay, if you are familiar with the concept of objects in IT or in programming, you could also think of objects as entities. Okay, so basically, from the parent, okay, the parent receives as well as transmit, okay, information. So basically this line represent direction, okay, represents direction and information coming in and out. So as you can see, in codicil, the parent receives data from the different child, okay, from the different nodes or child, okay, as well as it sends or it gives back the data from the parent back to that particular child. So as you can see, a closed chain of records in a navigational database model with next pointer, prior pointers, and direct pointers provided by keys in the various record. Basically, when we are talking about next pointer, it tells us or it simplifies data that is requested from the parent. Okay, so this line represents the data requested by the child to the parent, while this line okay, is the data given by the parent to the child, which the first, because in this example, the nth child is the one that is requesting the data. So in order for the data to pass through the next children, it must pass through to the first, the second, up until the nth children. So data is not directly requested. It must go or pass through a child entity or a child object first. Okay. Illustration of an empty set. So basically, in this particular example, we do not have any child. Okay. So basically, what happens is that the data is circulated back to the parent. Okay. Now, this one is a Bachmann diagram. So in this example, this is what happens. Now, under the expanded diagram, customer 1 has an order 1, has an order 2, and has an order 3. Okay. That particular order is sent back to the customer. Okay. So basically, we are getting all the orders of our customer, and then after getting that that particular order is that particular customer has ordered order 1, order 2, and order 3. After he or she finishes his order, it goes back to the customer 1 for confirmation. Okay. Now, in this example, we have customer 2, and he or she orders order 4 and 5. After he or she has confirmed his order, it will go back to the customer for verification and for finalization. Now, this is a representation of the Bachmann diagram in which the customer and the order, okay, has a relationship, okay, signified by this particular line. We will go on discussing relationship between objects or entities on the later part of our class or lectures. So for now, just think of a network model as something as that of a network data model. For example, is Codacell. Think of it as that of a data model that has to pass through other entities or objects before it can be finalized or before it can be used. Okay. In the late 1960s, IBM developed the Information Management System or IMS DBMS, used even today in many major installations. It formed the basis of the alternative data representation framework called hierarchical data model. Sabre system for making airline reservations was jointly developed by American Airlines and IBM or International Business Machines around the same time, and it allowed several people to access the same data through a computer network. In 1970, Edgar Codd at IBM San Jose Research Laboratory proposed a new data representation framework model called the Relational Data Model. Okay. This proved to be a watershed in the development of database system. It sparked the rapid development of several DBMS based on the relational model, along with the rich body of theoretical results that placed the field on a firm foundation. Because of his work, Codd won the 1981 Turing Award. Now, as we have discussed earlier, this is an example of Codacell, which is a network data model. It was followed by the hierarchical data model, which unfortunately we do not have any sample figures. For the second figure, which is the relational model, this is in fact the most used database model as of this period or as of today. Basically, in this concept, you can see rows and columns. Okay. Now, the rows and columns make up what we call a table. So the table has a header and a body. Okay. Now, the columns represents the attribute and the rows represent the values for each column. That is how a relational model works. So basically, you are building a table or making a table with columns that is considered as attributes or properties and rows which are the values for that particular column. In the 1980s, the relational model consolidated its position as the dominant DBMS paradigm, and database systems continued to gain widespread use. Advantages of DBMS. What are the advantages of having a database management system? The first one, data independence. Application programs should not, ideally, be exposed to details of data representation and storage. The DBMS provides an abstract view of the data that hides such detail. Basically, when we say data independence, okay, each and every data are independent to each other. We do not have to know, okay, where the data is stored. We do not have to know how the columns and rows are arranged or created. We do not have to know the particular data type of a row or a column. Okay, that is data independence. What happens is the database management system provides a view or provides us with the actual data that we need. Okay, it will not provide us or it it is not required to provide us the specific details of a particular table or tables. Okay, that's why it states here that it is an abstract view. Okay, when we mean abstract, it's just basically a representation, just like abstract painting. Okay, it does not need to be precise. It does not need to be in that particular representation as long as it provides the, the particular data that we need for our application. Now, efficient data access. Efficient data access pertains to the DBMS utilizing a variety of sophisticated techniques to store and retrieve data efficiently. This feature is especially important if the data is stored on external storage devices. A database management system provides us a means of saving the data, okay, efficiently, okay, without us or without having the user to program particular commands or create particular commands each and every time that we need to store or access the data that we need. Okay, so DBMS handles everything with regards to storing and retrieving data. Next, data integrity and security. If data is always accessed through the DBMS, it can enforce integrity constraint. It can enforce access controls that govern what data is visible to different classes of users. Now, in short, DBMS allows us to have different levels of access for different users. For example, if you are only a particular user, just like in Canvas, if you are only a student, okay, there are only particular links that you can access. If you are a teacher, there are also particular links that you can access. No user can have all the access without proper permission from the database management system. Also, when we access data in a DBMS, for example, you have access the letter A in column number 1. When you come back the next day and you retrieve that particular data, it should still be column number A unless someone has updated, modified, or deleted that particular data. DBMS has rules that allows us to make sure that the data that we have seen or is seeing is the same with all of the users of our system. Next, data administration. So when several users share the data, centralizing the administration of data can offer significant improvements. Basically, data administration pertains to how data is handled, data is shared, and data is accessed among all users of a particular database. Concurrent access and crash recovery. Concurrent access pertains to how many users can access a particular data all at once, while crash recovery pertains to what happens when your database crashes. For example, in the event of a power failure or your storage devices have failed, what are the options in order for us to bring back the data online or to recover that particular data? Lastly, reduce application development time. DBMS supports important functions that are common to many applications accessing data in the DBMS. So through the use of DBMS, whether you are developing or using it for applications, whether you are accessing it from a smartphone, from a computer, or from any device, it allows us to have reduced application development time because all the codes are standard. The codes for accessing, modifying data are the same. You do not need to have any special commands when you are programming, for example, in your smartphone. Okay. All the commands for developing in a smartphone and for developing a database application in a desktop are the same. Next, when we say databases, they are specialized structures that allow computer-based systems to store, manage, and retrieve data very quickly. So when you say database, okay, you are talking about specialized structure, okay, that store, manage, and retrieve data very quickly. Okay. These are computer databases. As I have told you in our introduction, manual systems can also be considered as databases. However, there are differences in storing, managing, and accessing data based on how the data is stored. Next, when we say data, we are talking about raw facts. The word raw indicates that the facts have not yet been processed to reveal their meaning. So when we say data, does it mean anything? None. We need to process data in order for us to what? To have information. So when you say data, data are meaningless unless you process them or you use them. Okay? Always remember that data are meaningless unless processed. Okay? It's the same thing as gold. Gold can only be sold and can only be bought and can be turned into jewelry once it is refined and processed. Okay? Information is the result of processing raw data to reveal its meaning. Data processing can be as simple as organizing data to reveal patterns or complex calculations such as making forecasts or drawing inferences using statistical model. Okay. In this information age, the production of accurate, relevant, and timely information is the key to good decision making. In turn, good decision making is the key to business survival in a global market. We are now said to be entering the knowledge age. Data are the foundation of information, which is the bedrock of knowledge. Okay? Data are the foundation of information, which is the bedrock of knowledge. That is the body of information and facts about a specific subject. Knowledge implies familiarity, awareness, and understanding of information as it applies to an environment. A key characteristic of knowledge is that new knowledge can be derived from old knowledge. Okay. Now looking at figure 3, you can see basically this is an inverted pyramid. So if we are to follow the definition here in this lecture, we could put the 3 data entities below, processing in the middle, and information on the top, because data is the foundation of information. What is the foundation of information? When you say foundation, it is the base. So data, base. So you get the meaning, or have you thought about why a database is called as such? It's because data is foundation of anything and everything involving information. So in this example, we have seen that data needs to be processed, and after processing, that is information. Now, we have also discussed that new knowledge can be derived from old knowledge. A perfect example could be Facebook. Now, Facebook did not become as the platform that we know today without previous networking sites such as what? Friendster, MySpace, okay, and the likes. Basically, as you may have noticed, Facebook updates every once in a while, and then it changes how things are displayed, it changes how things are viewed, it changes how things are communicated. In the early times, Facebook does not have a messenger. Basically, if you want to message someone, okay, you need to use the messaging feature of the Facebook website. Now, if I'm not mistaken, 3 or 4 years ago, it separated the messenger from the actual Facebook platform. So why do you think that happened? It happened maybe because they have noticed that users, or some uh, users of the platform has been using it only to communicate, while some has been using it to browse certain information. Okay. Now, in that example, we have seen that from the old knowledge, Facebook was able to create new knowledge. Then maybe a year from now or 2 or 3 years from now, Facebook might evolve again. Okay, and then it will become old knowledge, and then a new product or a new platform might become the new knowledge. So it is only a cycle. So let's summarize some key points. First one is data constitute the building blocks of information. Information is produced by processing data. Information is used to reveal the meaning of data. Accurate, relevant, and timely information is the key to good decision making. So good decision making is the key to organizational survival in a global environment. So for number 5, what is the perfect example? The perfect example is everything that is happening now around the world. If one country is to survive the global pandemic, and in order for that country to save the lives of the people in their country, they need to have accurate, relevant, and timely information. And they need that information in order for them to come up with a good decision making on how to address the problems faced in a particular area or region of their country. Okay. Now in figure 4, we can see here the data information and knowledge concept by Chaffee and Wood. Okay. It says here the value signified by the line. So the value of knowledge is very high. The value of data is low. Okay. Now, in order for you to have data, you need to process it in order for it to become information. Now, from the information, you use it as knowledge and then you apply it to certain events or problems. Next, data management. So data management is a discipline that focuses on the proper generation, storage, and retrieval of data. Given the crucial role that data play, it should not surprise you that data management is a core activity for any business, government agency, service organization, or charity. Now we have another meaning for database here. A database is a shared integrated computer structure that stores a collection of end-user data and metadata. Okay. End-user data are raw facts of interest to the end user, while metadata is data about data, through which end-user data are integrated and managed. So metadata, another term for here is properties. So you have data and properties. So metadata is the properties of your data. Okay, so for example, you are a student. So the student data has a metadata of what? You can have a name, age, address, course, year, subject, etc., etc. A database management system, or DBMS, is a collection of programs that manages the database structure and controls access to the data stored in the database. So under figure 5, we have the interaction of data. So coming from the app or user. And then we have DBMS, which is the actual software or program running on the computer. And then we have the database, which is stored on a physical storage. Now, without DBMS, we cannot access the data stored in the DBMS, as well as we cannot directly store the data from the app or from the user to the database. The database management system serves as a gateway, a boat, an airplane, a jeepney, or a tricycle in order for the user or the app to go to a particular direction that they want. Okay. Now, the line here, as you can see, it says here that it is an API. What is an API? An API is an application programming interface. Basically, an API is something or a collection of protocols or programs that is used for you to connect to the database management system. So you do not need to have the particular knowledge with regards to the database management system. All that stuff that you need to access, manage, store data is found in the API. So once you have studied the API, no matter what different applications or users are connecting to the database, you could use that particular database management system. Okay, so that would be it for our Unit 1 lecture. So check your kindly check the task that I have assigned in the laboratory part of your IM 101. So I have already set the schedule on which it needs to be passed. So for any questions, just kindly drop your inquiries in our discussions link. So please do not be intimidated. If you cannot ask questions in English, you could ask questions in Tagalog or in Filipino, rather, and I will answer you as soon as I can. Now, as I have said, please try to use English as much as you can in order for you to practice your speaking skills in your future endeavors. Okay? So this is Romel Apostol, MIT, thanking you for your time and hope to see you again soon.